Hello my friends, welcome to my Energy Economist channel. In this video, we're gonna talk about preparing to drill. So stay with me. Once the site has been selected, it must be surveyed to determine its boundaries, and environmental impact studies may need to be performed. Lease agreements, titled and right-of-way accesses for the land must be obtained and evaluated legally. For offshore sites, legal jurisdiction must be determined. Once the legal issues have been settled, the crew goes about preparing the land. Preparation is essential and involves the following steps. 1. Land is cleared and leveled, and access roads may be built. 2. Because water is used in drilling, there must be a source of water nearby. If there is no natural source, a water well is necessary. 3. Reserve pit, which is used to dispose of rock cuttings and drilling mud during the drilling process, and which is lined with plastic to protect the environment, is created. If the site is an ecologically sensitive area, such as a marsh or wilderness, then the cuttings and mud must be disposed off-site. It may have to be trucked away instead of being placed in a pit. Once the land has been prepared, several holes must be dug to make way for the rig and the main hole. A rectangular pit is dug around the location of the actual drilling hole. The seller provides a workspace around the hole for the workers and the drilling accessories. The crew then begins drilling the main hole, often with a small drill truck rather than the main rig. The first part of the hole is larger and shallower than the main portion and is lined with a large diameter conductor pipe. Additional holes are dug off the site to temporarily store equipment, after which the rig equipment can be brought in and set up. Well drilling has gone through major developments of drilling methods to reach the modern method of rotary drilling. In this method, a drilling bit is attached to the bottom end of a string of pipe joints known as a drilling string. The drilling string is rotated as a surface, causing rotation of the drilling bit. The rotation of the bit and the weight applied on it through the drilling string causes the crushing and the cutting of the rock into small pieces. To remove the cuttings from the hole, a special fluid called the drilling fluid or the drilling mud is pumped down through the drilling string, where it exists through nozzles in the bit as jets of fluid. This fluid cleans the bit from the cuttings and carries the cuttings to the surface through an annular space between the drilling string and the wall of the hole. At the surface, the mud is screened to remove the cuttings and is circulated back in the drilling string. The drilling operation is performed using huge and complex equipment known as the drilling rig. During a well test, a transient pressure response is created by a temporary change in production rate. The well response is usually monitored during a relatively short period of time compared to the life of the reservoir, depending upon the test objectives. For well evaluation, tests are frequently achieved in less than 2 days. In the case of reservoir limit testing, several months of pressure data may be needed. In most cases, the flow rate is measured at surface while the pressure is recorded downhole. Before opening, the initial pressure is constant and uniform in the reservoir, During the flowing period, the drawdown pressure response is defined as follows. When the well is shut in, the build-up pressure change is estimated from the last flowing pressure. The pressure response is analyzed versus the elapsed time since the start of the period, time of opening or shut-in. Well test analysis provides information on the reservoir and on the well. Geological, geophysical, and petrophysical information is used where possible in conjunction with the well test information to build a reservoir model for prediction of the field behavior and fluid recovery for different operating scenarios. The quality of the communication between the well and the reservoir indicates the possibility to improve the well productivity. Usually, the test objectives can be summarized as follows. Exploration well. On initial wells, well testing is used to confirm the exploration hypothesis and to establish a first production forecast. Nature and rate of produced fluids, initial pressure, and well and reservoir properties. Tests may be limited to drill stem testing only. Appraisal well. The previous well and reservoir description can be refined by testing appraisal wells to confirm well productivity, reservoir heterogeneities, and boundaries, drive mechanisms, etc. Bottom hole fluid samples are taken for PVT laboratory analysis. Longer duration testing, production testing is usually carried out. Development well. On producing wells, periodic tests are made to adjust the reservoir description and to evaluate the need for well treatment, such as workover, perforation strategy, or completion design to maximize the well's production life. Communication between wells, interference testing, monitoring of the average reservoir pressure are some usual objectives of development well testing. If you want to learn more about preparing to drill, you could do so in my book, Economic Study of Oil and Gas Well Drilling, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and don't forget to also hit the notification bell. Thank you for watching and goodbye.